Right, good afternoon. Welcome to the grade 8 mathematics class. And of course, today we will be looking at our maths grade 8, where we will look at Pythagoras. And of course, I want us to be able to investigate the relationship between the lengths and the sides of right-angled triangles. And this should be done by the end of this lesson. But we must also be able to determine whether the triangles are right-angled or not. And lastly, we should be in a position to calculate the missing lengths in right-angled triangles. So if there's any side that is missing, we should be able to calculate that using the formula that we're going to learn about on Pythagoras. And of course, what is very important is that we will also see how the formula is generated, the formula to calculate any missing value, and this must happen only in a right-angled triangle. That's where we will be able to determine the use of Pythagoras as a formula, but also its origin, just so that you have the historic background of how the theorem was navigated. Right. Without any waste of time, I, however, want to take you through something that you may already know. We should know by now that the square of a number is the value that you get when you multiply a number by itself. So the square of any number is the value that you get when you multiply a number by itself. And over the last few weeks, we have shown really that when you multiply a number by itself, you get something called a square number. I'm sure you will remember some of the values when we were working with sequences and series. We were able to tell that the number multiplied by itself gives you a square number. And basically that is what we did up to so far. We have been able to demonstrate the importance of multiplying a number by itself. So even today, we will do the same just before we can proceed with our work in relation to square numbers, which exist in the Pythagoras theorem. So consider the following. Consider the following squares. We have got 3 squared, which is a square number. And we should know by now that if you have 3 squared, that is when you multiply 3 by itself, 3 times 3 will give you 9. So 3 squared is the same as 3 multiplied by 3, which will give you 9. And we should know now that 9 is a square number. So 9 is a square number because we multiplied 3 by 3. Equally, when you multiply 7 by itself, we say that you have 49, and 49 is known as a square number, primarily because this is the 7 which is squared. So 7 times 7 gives you 49. And then the last one, of course, is 3 squared. And once more, you should be able to know that 3 squared simply means you are multiplying 3 by itself. So even when it comes to 7, 7 squared simply means that it's 7 times 7, which is 49. So I do appreciate the fact that by now you have got an understanding of how the square numbers work. And let us carry on. Right, just to demonstrate once again, we have the last example here of adding square numbers. The first one is 3 squared, and the second number there is 4 squared. So we have to add the two. And the most serious way in which you can do this is to firstly, find the value of 3 squared, and in this case, the value of 3 squared will be 9, because we've just shown it in the first example that 3 squared is 3 multiplied by itself, which gives you 9. So 3 times 3 is 9. And then the second one there, which is 4 squared, we've also shown you that 4 times 4 is 16. And of course, 16 plus 9 will give you 25. So basically, you've got 3 squared plus 4 squared, which is 25. So 3 squared is 9, and then 4 squared gives you 16. Right, and of course, the answer there will be 25. So 25 is the final answer that you get when you add the two. So basically, this is what we mean when we are talking about the different numbers where you are squaring the number as such. And of course, this emanates from the description that we've just shown, that when you square a number, you get a value in which you have multiplied a number by itself. So a square number is any number or it's any value that you get when you multiply a number by itself. So remember, 64, for example, is one of those numbers which are also known as square numbers. You can mention quite a lot. If I can just ask you to mention a few, you should be able to mention different numbers there. So I see that our group chat is quite empty today. But of course, let's carry on to demonstrate other square numbers. 81 is one such number. A square number, if you may call it, because it is a product of a number which has been multiplied by itself. That number is 9. Even 100 is a square number because a number that is multiplied by itself, in this case, that will be 10, because 10 times 10 will give you 100. So basically, 100 is a square number. That's how we define it, as a square number. And then, of course, we multiply a number by itself. So Can we now carry on just to also demonstrate the importance of using these square numbers in Pythagoras? But before we get there, let's now utilize the following examples where I want you to just find the different values. Before we go there, let me see, there's something on the chat. All right, thank you very much indeed. Hakim, I can see what you have just said there about the previous question on patterns. Your point is noted with thanks. Hakim chatting to me there privately. Thank you very much indeed, Hakim. Right, we carry on now just to also simplify the different expressions, and I want us to simplify the following. We have got about 5 different activities, and I want us to square the numbers. And of course, the monomial as well, which is now found in C, just to square that monomial, just to simplify the expression. So this is a class activity. Please take out your pen and a paper and let us simplify these expressions. Let us simplify the expressions in this case. Right, let us simplify. Let us simplify. We have got a squared, and then I see that we have, let's see, the person who has just said something on the group, Natalie. Yes, Natalie has said the answer is 16. But I see you have corrected yourself once again to say, no, it can't be 16 because you say that's wrong. Okay, Natalie, I hear what you're saying. I hope that you are busy reworking it out. I'm glad that you have seen the mistake. 8 squared cannot be 16. Remember, if you add 18 and 8, if you add 8 plus 8, yes, you get 16. But in this case, this is a square number. So I can see Lesedi has just chipped in there to demonstrate that we have 64 as the answer. So Natalie has come back now to also agree, and Natalie has found the answer to be 64. So thank you very much to both Katleho as well. I see your answer there, which is 64 as well. So far there are 3 learners, Lesedi, Katleho, and Natalie. I see Ntlantla, the 4th one as well, agrees with them. Ntlantla also found 64. Great. And I believe that this is basically what you have multiplied 8 by itself. And just to demonstrate that if you multiply 8 by itself, you should be able to get a square number, which is 64. So I also got 64 on my side. So which means that those learners who have just participated, you are correct when you say that 8 squared is equal to 64. So without any waste of time, can we zoom now into the next one, which is B. In B, you can see we have got 11 squared, and that is also a square number. Can we do the B there, which is also a square number, right? I see that there are almost four learners, Natalie, Katleho, Musa, and Lisedi. All the four learners that I've mentioned have already calculated 11 squared. And what they've not done was to just demonstrate that 11 squared simply means you multiply 11 by itself. So I think that is the most important thing which we need to do, just to demonstrate that if you multiply 11 by 11, you'll certainly get 121. So basically that is what you get when you multiply 11 by itself. So 121 will definitely be the correct answer. I see Ntantla has added a number there, 121 being the first of the answers that you have mentioned. Hakim says, okay, I see now. Right, thank you very much indeed, Hakim, Ntantla, Lisedi, Musa, and Katleho. So we are now going to proceed with the next one. Hakim says, I see your point. I'm glad that you now understand. So Natalie, I see you have 9A. And then of course, Katleho also has 9A, that is the C. Tinashe Ngube says 9A to the power of 2. So I see that you have got an answer there. The study also says 9A to the power of 2. So meaning that it's 9A squared. Right. I'm glad that Tinashe Ngube and Lesedi have been able to correctly capture the square on the side of the variable. So the mistake that some of the learners have made was to omit the square number there in terms of the variable, which is A. Remember that the 3A is inside the bracket. So basically, you are working with a number together with a variable, both of which are inside a bracket. So you can see that you have to square both of them. So technically, this means you square 3 and you must also square A. So basically you have got 3 squared and then you also have A squared. That is what you have. So if you simplify it, you must start by saying this becomes 3 squared A squared. In other words, every number there or every base must get its own exponent. So it is true that 3 squared is equal to 9, but what about A squared? So A squared is a variable, then you leave it as it is. You can just leave it as it is. So 9A squared will be the answer in C. I hope that it makes sense. And then alternatively, you can just say this is 3A multiplied by 3A. Remember, in mathematics, we say that there are, or we always say rather, there are many ways to solve a problem. There are different ways. So you don't have to follow the same method. You know, one can use the different method. So in the other case, just alternatively, 3A times 3A. You know that when you multiply the numbers first. So 3 times 3 is 9. A times A is A squared. So hence the answer 9A squared, as we have said, or 9A to the power of 2, just as Tinashe Ngube as well as Lesedi have said. Right, Tinashe, I see you have now zoomed into D, and of course you are proceeding to define the square root of 3. If you square that, the answer that you got is 3. And you are not alone. Lesedi, together with Khwitsi Mudimu, Chabane, as well as Ntlantla, they too have found that if you square the square root of 3, you get 3. So Natalie, asking a question there, how do we find that? So, great, Natalie. That is a good question. And I'm going to answer it as follows. Remember, every time when you have the square root, again, this can be answered in different ways. One way is to consider the following. The square root of any number, let's say we are talking about the square root of x, which is a variable in this case. The square root of x is the same as if you write the square root in the form of an exponent, the square root of x becomes x to the power of half. So that is what we mean. The square root of x is the same as x to the exponent half. The exponent there is half. So if you have the square root of 3, this is also the same as 3 to the power of half. All right. And remember that you have to square that, meaning that you have to multiply that expression by itself. So we are now going to say 3 to the power of half multiplied by 3 to the power of half, because the square root of 3 is the same as 3 to the power half. So 3 to the exponent of half multiplied by 3 to the exponent half. Remember one of the basic rules of exponents, and this is rule number 1 of exponents. And it says that if you multiply 2 powers with the same base, you add the exponents. So now we are multiplying 2 powers with the same base. We are multiplying 3 to the power half by 3 to the power half. So the base in this case will be 3. So you keep the base and then you add the exponents. The exponent will be half plus half. Each exponent there is half. And what is half plus half? This is equal to 1. So it means that your answer will be 3 to the power of 1. And 3 to the power of 1, as you know, is 3. That is one way of doing this. Alternatively, you can still have your 3 to the power half all to the power of 2. Now, there's also a definition of exponents. If you raise a power to the power, a power raised to the power. So 3 to the power half, all to the power 2. This means you'll just have to multiply the outside power there, which is 2. You multiply that by half. 2 times half gives you 1. So meaning that 3 to the power half, all to the power 2, will give you 3 to the power of 1. And this is the same as 3. I hope that it makes sense as we proceed to navigate these square numbers, proceeding to the next one, which is E. Thank you very much indeed. And Natalis agrees. I'm glad that you understood. Now can we do the very last one, which is now E? We need to now proceed just to E to demonstrate the correctness of the square root of 25 minus 9, all to the power of 2. So I see that Lesedi, together with Natalie, as well as Tinashe and Ngube, you have found 16 there. And by the way, I fully agree with you. 16 is the correct answer. But I just want to check, how did you find it? Because I wanted to clear one of the misconceptions which can happen at any time. One of the most serious misconceptions that can take place when it comes to solving problems of this nature. One of the serious problems that other learners have is the following. You can see we have the square root of 25 minus 9. Instead of subtracting 9 from 25, some of the learners may be tempted to falsely assume that you will have the square root of 25, which is 5, and the square root of 9, which is 3. So one of the learners may say the answer is 5 minus 3, you see, which is 2, which is 3, sorry. Sorry, that is 2, yes. 5 minus 3 is 2. And thereafter say 2 squared, which is 4. That is the serious misconception that can take place. Remember that the first thing to do when you are faced with a problem of this nature is to work out whatever that is inside the square root. If you are subtracting there, then you need to subtract. If it's addition, then you need to add. In our case, we have 25 minus 9. So we must first subtract 9 from 25, which will give us 16. So basically, you'll have the square root of 16 to the power of 2. And remember, I said to you already that the square root of 16 simply means 16 to the power of half. I'm glad, Lesedi, you have demonstrated the importance of working out the contents of the square root. And of course, Lesedi has shown that you first find the square root of 16, which is 4. And thereafter, 4 to the power of 2 is 16. Great. That is one way of doing it, Lesedi. I'm glad that, well, Preston, I see you are saying 16 times 16. Because in your case, you found 16 squared, which cannot be correct. Because 25 minus 9, yes, 25 minus 9 is 16. But remember, the 16 must be inside the square root. So basically, you have the square root of 16 all squared. You don't square only 16, President. You actually square the square root of 16. So that's basically what you need there. You need to say the square root of 16 multiplied by the square root of 16. So you multiply the square root of 16 by itself. And Lesedi, that method is also correct. I agree with you. You can simplify the square root of 16, which is 4, and then 4 multiplied by itself, that is 4 times 4, gives you 16. Lesedi, I fully agree with you. I hope that Preston can see the point that I'm raising. In your case, Preston, you don't multiply 16 by itself. You multiply the square root of 16 by itself. Yes, you are squaring now the square root, exactly, Lesedi, as you have said. I hear what you, that's a correct point, good point. So you square the square root. So the square root of 16, then squared. And of course, that will give you 16. You'll see that the square root of 16 multiplied by the square root of 16 gives you 16. Basically, that is what you have. That is the same as multiplying the square root of x by the square root of x. You get x. How do you get it? Because the square root is the same as the exponent, which is half. All right, so even in this case, it will be 16 to the power half times 16 to the power of half. They cancel each other. Yes, I agree. I agree, Natalie. That's the other approach. The square roots cancel each other. And I see Preston is asking, is it because of the brackets? Exactly. It is because of the brackets. You can see that the brackets have isolated the square, which is 2 there, the exponent, which is 2. And I see Lesedi says exactly. And now Preston understands. Great. I'm glad that you understood. So therefore, your final answer in this case will definitely be 16. So I'm glad we are done with that. So I've just demonstrated, this was the first one, which we did just to show that when you multiply 8 by itself, you get a square number, which is 64. So now I'm going to zoom directly into Pythagoras. I'm going to demonstrate Pythagoras now, and I want you to concentrate on the blue triangle. Can you see the triangle which is blue there? I hope that you can see that triangle, and I want you to concentrate on that triangle because I'm going to do most of my explanation based on that Pythagoras. And Natalie is asking, what is Pythagoras? Great, that's a good question. Well, the theorem of Pythagoras is named after a Greek mathematician known as Pythagoras. And this man has been able to prove that the square of the hypotenuse side is equal to the sum of the squares of the other two sides of a right-angled triangle. And this is basically what we are going to prove today. We are starting by proving his statement to be true. And we will learn more about him as we proceed. So Pythagoras basically was a mathematician who lived some time ago. I see that Lisette says pi. All right, the pi sign. All right, I see what you mean. Not the pi, it's py. So Pythagoras. Pythagoras. Okay, we'll look at that. You'll get the spelling now. I'll show you. I'll demonstrate some of the examples. What I'm trying to say here is in this blue triangle, you can see that any triangle has got three sides. In our case here, we are trying to prove that when you square the side, which is now the hypotenuse side, that square of the hypotenuse side will be equal to the sum of the squares of the other two sides. In this case, you can see we've got C is this side, and then B, the other side of the triangle, and then A. So basically we construct squares using these three sides. You can see that the side C there, we've constructed a square, meaning that this line C is equal to the original side there. So now, in such a way that when you calculate the area of the square, you get C squared. So basically, you find the area of the other square, the bigger square there, which happens to be C times C. And C times C is C squared. So that's how we get the C squared. So the C squared that you see here is the area of this particular square. And then you go and do the same with the other two squares. The area of this square will be B multiplied by B. And that will also give you a B squared. And the area of the last square is A times A, which is also A squared. So basically that's what we do. And we are going to show you now that this area, the area of this square, if this triangle is a right-angled triangle where the angle which is opposite the line C is 90 degrees. If this is a right-angled triangle, then we will conclude by saying A squared plus B squared must be equal to C squared. In other words, the area of this particular square here, which is A squared, and the area of this other square, which is B squared. If you add them together, they will be equal to the area of the bigger square. Let me go on to demonstrate what we mean there. If you have to understand this concept, I know that Natalie was asking what is Pythagoras. To understand this concept, we say that the sum of the areas of the squares on the legs of a right triangle is equal to the area of the square on the hypotenuse side. Now, consider this triangle here. This is a right-angled triangle. How do we know? Because of the side of 90 degrees there, which we see. The angle which is now surrounded by the squares. I'm talking about the triangle which is surrounded by the squares, has 90 degrees in it. And now, if you look at this side, which is B and A, those are the two legs of the right triangle. Why do we call them the two legs? It's because where they meet, they form 90 degrees. Where these two legs meet, they form 90 degrees. It is for this reason that we are saying, if you take the square, which is the bigger square there at the top, C times C is the area of that particular square. If you take the area of the bigger square, you will see that it will be equal to the sum of the two areas of the other squares. All right. It will be equal to the sum of the areas of the other remaining two squares. And this therefore means, because the area of this bigger square is C multiplied by C, which is C squared. The area of the one of the squares is A times A, which is A squared, followed by B times B, which is B squared. Therefore, we conclude by saying A squared plus B squared is equal to C squared. And basically, this is how we define our Pythagoras. And this relationship of these three squares, A squared plus B squared is equal to C squared, where C is known as the hypotenuse side. This relationship is known as Theorem of Pythagoras. And as Natalie was asking, it is named after the ancient Greek mathematician known as Pythagoras. He's the only one who was able to prove that this relationship is true for all right-angled triangles. Therefore, the equation for the theorem of Pythagoras is known as A squared plus B squared is equal to C squared, where A and B represent the legs of the right triangle, and C represents the hypotenuse side. This hypotenuse side is the side that is opposite the 90 degrees. I hope that this definition is clearer. All right, so I see Natalie says A plus B is equal to C since when? Not just A, it's A squared, remember. It's not A plus B plus C, it's A squared plus B squared is equal to C squared. All right, A squared plus B squared is equal to C squared. It may look complicated as we start, but as we carry on, you will be able to see, because right now I was just giving you the origin of the theorem of Pythagoras. So let me simplify it now. Now I'm going to simplify it. We're going to zoom now directly into only a triangle, no more squares. So forget about the squares for now as we proceed to the next example. So let's look at this triangle. We have got triangle A, B, C. Can you see that triangle? And we say that the line AB is a perpendicular line. It's perpendicular to the base, which is BC. And what do we understand by the term perpendicular? The term perpendicular means where the line is joined with the base, an angle is formed. And that angle is known as the right angle. Others call it 90 degrees. So the right angle is also 90 degrees. That is what we mean. It is formed when the two legs are joined, AB and BC. And the remaining side, AC, as you can see in the triangle here, we call that the hypotenuse side. This is the hypotenuse side. And in terms of Pythagoras, the hypotenuse side, if you square it, in other words, AC, if you take AC squared, Natalie, I'm sure you can now see, AC squared, you square it, it's not just AC, it's AC times AC, you multiply it by itself. So it's AC squared is equal to AB squared plus BC squared. Basically, that is what we mean when we talk about the theorem of Pythagoras. This is a practical example now. I'm giving you a practical example which is very clear. And of course, we are going to use Pythagoras. You can see now I've given you a triangle with two sides that are known. One of the sides is 5. Can you see the side 5? And the other side is 7. And then the last side is C. That's the unknown. Now, you can see that the unknown side is opposite the 90 degrees. How do we know this is a right angle triangle? We know because the two legs, 5 and 7, where they meet, where these two legs meet, a degree is formed, an angle is formed, and that angle is 90 degrees. Therefore, in terms of the theorem of Pythagoras, the square on the hypotenuse side, which is C, if you square C, this will be equal to the sum of the squares of the other two sides. In other words, C squared is going to be equal to A squared plus B squared. And in this case, our value of A will be 5. And our value of B will be 7. This therefore means C squared is equal to 5 squared plus 7 squared. And 5 squared, by the way, is the same as 5 times 5, which is 25. And 7 squared is the same as 7 times 7, which is 49. And of course, if you add 25 and 49 together, you get 74. Therefore, to find C, you'll have C being the square root of 74. And the square root of 74 is approximately equal to 8,6023. So basically, this is how you find the hypotenuse side. So the hypotenuse side, Lisedi, you are saying, what is the hypotenuse side? The hypotenuse side is the side which is found in a right-angled triangle. And that side is opposite 90 degrees. So even if you change even if you change your triangle and you know, even if you round off your, or you rotate your triangle rather, it doesn't matter. The side that is opposite 90 degrees will always be known as the hypotenuse side. And I want us to use this lesson to also look at the following example here. I'm giving you an additional example now. You can see that we have got the hypotenuse side, which is x, And in order to find the hypotenuse side, you square it. You'll say that a squared plus b squared is equal to c squared. That is the formula for Pythagoras. Of course, x squared will be equal to 11 squared plus 9 squared. And 11 squared is the same as 11 multiplied by 11, which is 121. And then 9 times 9 is 81. And of course, if you add the 2, you get 202. Therefore, the square root of 202 will be 14,21 centimeters. So basically, that is what you have. So this was another example of Pythagoras, which we will certainly use going forward to find any missing sides, as I said in the beginning of the lesson. And to wrap it up, there are 4 things that you need to remember. The first thing is that the leg of the right triangle and the other leg, where they meet, they must form a symbol there, which is known as the right angle or 90 degrees. And the last side, which is opposite the 90 degrees, is known as the hypotenuse side. But remember that the theorem of Pythagoras says if you have got a right angle triangle of this nature, a squared plus b squared is equal to c squared. Basically, that is what we have. And this brings us to the end of today's lesson. I hope that you will take the time to reflect. Let me leave you with this homework. If a triangle PQR is a right-angled triangle where Q is 90 degrees, then find the hypotenuse side. Tell me, is the hypotenuse side PQ or QR or PR? Just consider it. Draw this triangle PQR on the paper and identify Q as 90 degrees. And then tell me which side will be the hypotenuse side. This lesson was brought to you by the STEM Digital School in partnership with the Sasol Foundation. Until we meet again next week, thank you very much.